This content is brought to you by Mazunder Academy.
Hello everyone. In this lecture we are going to study data visualization in R. So for a given data set, how to draw histogram, how to draw frequency polygon, how to draw ogive, how to draw pie chart, how to draw bar plot, then how to draw box plot, and finding any outliers available in the data set. So these all concepts we will study one by one. So without further delay, let us start the demonstration. In this demonstration, I will use CO2 dataset, which is an inbuilt dataset in R. So first of all, if we want to visualize this dataset, what is the structure of the data or what are the columns, everything. So the code here is view CO2. If we run view CO2, we can see inside CO2 dataset, plant, type, treatment, concentration, uptake. So these are 5 different columns. Some of the columns have numeric data like concentration and uptake. These all data are numeric data, I mean number data, and plant, type and treatment, they are categorical data. So let me go back to the program. Now if we do attach CO2, that means if we run this code, then CO2 will be attached to this environment, and if we want to refer any of the column of this CO2, we can directly access the column. No need to follow the path like CO2 dataset name and then $column name. No need that. We can directly access any of the column. For example, let me run this CO2. It is attached now, and if I want to print any of the column, for example concentration CONC is one of the column, I can print CONC. So if I just run it, we can see all the concentration data available here. Otherwise I have to write CO2 concentration, CONC. So this is the benefit if I attach the data set. Now for example, one question here, write a program to draw a histogram using uptake data. That means we are going to use this uptake data and we want to draw a histogram. So we can see there are 84 data in this data set. I mean there are 84 rows and 5 columns. So if we consider uptake data, then there will be 84 data in this uptake column. So we will use this uptake data and we will draw a histogram. That is our question now. So first of all, let me give you a little idea about histogram, how it looks like. Generally, histogram is a graph. It looks like this. Along x-axis, these are the class boundaries, and along y-axis, these are the frequencies. And class boundaries, in our case, it is not given, so we have to make our class boundaries, and then corresponding frequencies, we will calculate what will be the frequency corresponding to our generated class boundaries. So let me go back to the program. So first of all, we have to decide how many classes. For example, in this question, nothing mentioned, so we considered 7 classes. You can take 6 classes or 5 classes as you wish, but if you take little good number of classes, your histogram will be looks nice and it will give us a good presentation, and we can understand some of the information, we can infer some of the information from the histogram. So we have considered 7 here. There is no hard and fast, you have to consider 7, you can take 8 also, no problem. So first thing is number of classes. Like for example, in this case, how many classes? 1, 2, 3, 4, 5, 6 classes considered, and then drawn the histogram. So we are considering 7 classes. Now after finalizing number of classes, now it is time for us to determine the width. What is the meaning of width? For example, here class boundary is 5.5 to 10.5. So if you subtract 10.5 minus 5.5, it is 5. So 5 is the width of the class. Each class, if you see the width, it is 5. So to determine width, we have to know what is the highest data and what is the lowest data available in our data set. And if we see, it is very difficult here by seeing through naked eye a function called range. Range is a function that will give us the smallest data and highest data available in the data set. As we are going to use uptake data, so we will apply range function on uptake data, and if I run, we can see it is giving us here 7.7 is the smallest data and 45.5 is the highest data in the uptake data set. Uptake data, if I run, so we can see this is the structure of uptake data: 16.0, 30.4, 34.4, 37.2, 35, 43, 43.4, like this, 19.9, 17.9. Once we see the range of this data set is 7.7 to 45.5, so we can now define our width. So width, generally it is a integer value. Okay, width we always keep it an integer value. So how can you define the width? Highest value minus lowest value divided by the number of class. And for example, if this data, if I show you 45.5 minus 7.7, 37.5, and divided by number of class 7, so it is 5.4. so we need it round to the next integer. So to round to the next integer, that is 6, there is a function called ceiling. Ceiling function will round the result. For example, 5.4 will be rounded to 6. So we can see this if we just run width, and then we can see the width is 6. So uptake, no need for me, I can delete it. Width also actually no need, I can delete it. It is I kept it just to see whether width is properly working or not, or even we can keep it, no problem. Now once we have width, our job is to make the class boundaries. We can start from some fixed number that should include our lower limit of the data and plus width. For example, our smallest data is 7.7. So if I start from 7, that is okay. So there is a function called sequence. So sequence will start from the first number, that is 7, and then it will go up to 7 plus width multiply the number of class. That means what? 7, if I show you in calculator, width is 6 multiply number of class 7 equal to 42 plus 7, so 49, and my maximum data is 45.5. so maximum data is covered up to 49. Within 49 all data will be covered. So sequence function, the initial value will be 7. It will start from 7 and it will go up to 49, and then gap will be 6. Each gap will be 6. What it means? First value will be 7, then 7 plus 6, 13, 13 plus 6, 19, like this it will reach up to 49. So if we run it, we can see the breaks data are 7, 13, 19, like this up to last data is 49. So these are the classes: 7 to 13, 13 to 19, 19 to 25, 25 to 31, 31 to 37, 37 to 43, 43 to 49. These are the different classes we have. Now it is our time to draw a histogram. So I will show you histogram in different steps. For example, the first, hist is the function which will draw us histogram, and we are passing the parameter uptake data. The data available in uptake that will be used for drawing histogram, and it should use the class that is defined here by this sequence function, which is stored in the breaks. So based on the breaks, it should draw our histogram. So let me make it little bigger, because to see the histogram we need this area should be little bigger, otherwise it will not draw the histogram. So let us draw. If you run this, you can see the histogram has been drawn here for us. Now if we see the limits or x-axis data, it is not properly appearing. So we can control this by giving this x-axis parameter, x-a-x-p, x-axis parameter. So what is that? It should be given as a vector. First one 7, second one is 49, and third one is the parameter, that is number of classes. So if we run this, it will draw a histogram with this x-axis parameters. So I will show you. If I run, we can see it is very nicely as we are expecting, the exactly same way it is showing us. 13 to 17, this is the rectangular bar. Then 13 to 19, this is the rectangular bar. And if we see the count here, in this 13 to 19 there are 15 data. Similarly 7 to 13, maybe 11 data, like this. We will see the number of count here, how many data in each of these classes. If we want to see this count, there is an option called label. So labels equal to true. So if we add another parameter in this hist function as labels equal to true, then you can see this label will be shown here. So you can see 7 to 13 in this category 11 data, 13 to 19 in this category 15 data, similarly all. And this one, if we make it bigger, so we can see it, so it is 19. Next part is maintaining colors. So if we want to maintain different colors, there are many ways. Two ways I will discuss. One is we can add a parameter in hist function as col. So col equal to one vector c, and then whatever the color you want. For example, I want the first bar should be red, second bar should be orange, third bar should be yellow, then green, then blue, then violet, like this. So all whatever you want the colors, you will put them in a vector, and that should be assigned to color col. And if you run this exactly as you have described, the same way it will put the colors. Sometime if number of bars more, then it is difficult to write or time consuming to write this all different colors. In that case, there is a shortcut. We can use rainbow color. There is a function called rainbow, and you can pass this parameter how many different colors it should use. So I have 7 different bars, so I will put 7 here. And also if you want to give some x-axis name, by default it will take the dataset name and frequency here. If you want to give your own name, you can give, like xlab means x level, within double quotes you give whatever you will give, it will appear in the x-axis in place of uptake, and then y-axis whatever you will write, it will come here, frequency or whatever. This frequency is by default. Then if you want to give some name, histogram of uptake, this is by default system assigned. So if you want to give some another name, anything, histogram of uptake data in CO2, something like this I have given here. So that can be given by main. Main is the one to which if you assign some text, this will be appeared in the as a name of this plot. So if you run it, we can see another set of colors used, and that is rainbow color. 7 different colors used, and the name is histogram of uptake data in CO2. Whatever I have given here I have given class boundaries, so class boundaries appeared here. Here I have given frequencies appeared here. So this is that basic histogram that I have explained here, but there are different functionalities, like for example, if you want to give some border here, or if you want to different way of shading, that all possible, but I will leave that part for the viewers. You can explore it. Next we are going to see how to draw frequency polygon for the same data set. Now frequency polygon, before starting let me explain how frequency polygon looks like. So a frequency polygon will looks like this. There will be class boundaries and frequency. These two data when it is available to us. So first work is we need to find out the midpoint. How to find midpoint? Upper limit plus lower limit divided by 2. And then all the midpoints when we have found, then along x-axis all the midpoints you will place, and along y-axis all the frequencies. There is a point, like if we see the midpoints starting from 8 and it is ending with 33, but in the frequency polygon you can see 8 here and 33 here, and beyond these two, smallest and highest value of these midpoints, there are two extra points. One is 3, another one is 33. We need to take two extra point, one to the lower side and another one to the upper side, just to close the polygon, because polygon is a graph, it is a closed graph. Just to close the polygon we need to take two extra midpoints whose frequency will be 0. So if we see how much is the gap or width here, 8 plus 5 13, 13 plus 5 18. So 8 minus 5 will be the previous midpoint. So 8 minus 5 is 3. Similarly 33 plus 5 will be the next midpoint, so it is 38. And then against 8 frequency 4. So against 8 you put the frequency, the one dot here, mark the point. Then against 13 it is 6, mark it. Similarly against 18 it is 11, mark it. Against 23 10, against 28 7, against 33 5, and 38 and 3 will be frequency 0. Then you just by straight lines you join all these points, and that is our frequency polygon. So now we will go for doing this all through program. First of all, we see all the midpoints. H is the variable where we have stored the output of the histogram, and if I want to show you, if I run this H, what is the value of H here? We can see this is the output for H. Yeah, so H have these columns: breaks, then counts, then density, then mids. So mids are the midpoint of the class. For example, what is the midpoint of 7 and 13? 7 plus 13 20, 20 divided by 2, that is 10. So first midpoint is 10. Then 13 plus 19, 32. 32 divided by 2 is 16. Next midpoint. Now we can see 16 minus 10 is 6. So we can just simply add 6. So 6 plus 6 12, that is 22. 22 plus 6 28. 28 plus 6 34. 34 plus 6 40. 40 plus 6 44. So these are the actual midpoints. We need to take two extra points. So we can see here how we can do that. Now H counts, we have the frequency. all the frequencies available. You can see 11, 15, 9, 13, all these frequencies available where it is under H count. So midpoints I have taken as a variable, new variable, and we want to, as I said, we need 2 extra point. So how can we do the extra point? The minimum of these midpoints, H mids, okay, minimum of this H mids minus width. As I said in the example, 8 minus 5, that is 3. So here is the minimum of H mids will be 10. So 10 minus width is 6. So 10 minus 6 is 4. So 4 will be the first data here, and then all the H mids, that means 10, 16, all up to 46, and then maximum of H mids, that is 46 plus width. So 46 plus 6 will be 52. So if I see my midpoints now, my midpoints, if I just run, we can see the midpoints are starting from 4 up to 52. And 4 and 52, these are 2 extra midpoints we have taken. After that, we need to add frequency also in the frequency column, because currently I have only the frequencies 11, 15, 9 and 13, 14, 19 and 3. But to close against 52 I need frequency 0, and against 4 I need frequency 0. So exactly same way we need to add 0 along with the H counts, because all the frequencies available in this H counts. So 0, H counts and 0. So 0 and 0 will be added, will be concatenated with the all data of H counts. And if we run this, and frequency 1 is the variable. So if we run this 2, then we can see 2 extra frequencies 0 and 0 added to the previous frequency count. Now everything is ready. It is time for us to draw a frequency polygon. We can use the function plot to draw frequency polygon. So plot function, and its parameter will be along x-axis it will be midpoints, and y-axis frequency 1. So if we just draw this with the basic, for example, let me show you just basic one. If I show you, if we run, it is showing just like this without any line, just the points 0, then 11, then 15, like this, these all points. Now if we want to draw it with line and point both, then we can write it type equal to b. So if I write type equal to b here, another parameter, and if we run, then you can see the frequency polygon is drawn here. Now it is our time, how much decoration we want to do, we can. Similarly, if we want to assign some x-axis points, we can do start from 4 up to 52, and how many in between n class plus 1, and then PCH means plotting character. By default it is a like hollow circle. If you want, in place of hollow circle, if you want star or some other character, you can pass as a parameter of this plot function PCH equal to star. Then the color is black. If you want some other color, you can give, for example, you want say red color, okay, so red color, it will be red. Okay, LWD, line width is 3 means it is right now it is very small. So if you you change this data parameters, and you can see the difference here. So line width will be 3, color red, plotting character star. So it all will be replaced, this all hollow circle will be replaced by star. Then all x-axis will be like 4, 10, 16, 22, 28 up to 52. And then if you want to give some name, so you can give one name here, frequency polygon. So if we run this one, we can see it will give us as we are expected. So we can enlarge it to see it properly. So we can see it is showing the frequency polygon here along with the levels. So this is about, if you want to show this I mean the values here, that also possible you can do. You just explore it. For that, as we have shown in histogram, you can explore it and you change the values and change the star, change the color, everything you change. Type, here I have written B, you can write only P, means only point. Okay, you can write only L, L means only line, no point. B means both line and point. Okay, so this is all about frequency polygon. My next drawing is Ogive. So before starting the code, let me take to the theory of Ogive. So Ogive is a graph between class boundary along x-axis and cumulative frequency along y-axis. So in your question, class boundary will be given, I mean theory question, class boundary will be given and frequency will be given. So we have to find out the cumulative frequency. So how can you find? First, frequency here 3, then 3 plus 6, 9, answer here, 9 plus 8, 17, right here, 17 plus 9, 26, right here, 26 plus 7, 33, right here, 33 plus 3, 36. So this is the cumulative frequency column, and here you can write 5.5 to 10.5 the first class boundary, then 10.5 to 15.5 second class boundary, similarly up to 30.5 is the last boundary. This all points, I mean class boundaries, you will write here, and then you will put these frequencies, I mean cumulative frequencies corresponding to the upper limit. For example, 3 will be placed against 10.5, then 9 will be placed against 15.5, then 17 will be placed against 20.5, and similarly 36 will be placed against 35.5. So once you have placed all these values, you just close, and the first class boundary, that is lower limit of the first class boundary 5.5, it is considered its frequency 0, cumulative frequency 0, and then you will join by straight lines all these points and your graph will be looks like this. So this is Ogive, and now we need to do it using program. So Ogive, for that, as we have seen, cumulative frequency we need to calculate. There is a function called cum sum, cumulative summation, and this all frequencies available in h count, so h dollar count. So this will give us all the frequencies, and cum sum, it will give us all cumulative frequencies. And as I said, we need 0 for the initial frequency, so that one extra frequency just to close the Ogive, we need this 0 to be included in our cumulative frequency, although it is not there in the table. So that's why using the concatenation function C, it will concatenate 0 at the beginning and then all the cumulative frequencies will be there. So if we just want to see how it will work, so we can see 0 is added here, and then 11, 26, 34 up to 84. And if we see the breaks, so what will be the breaks? You can see our breaks are 7 to 13, 13 to 19, that already we have seen up to 49. Now plot. So these are the class boundaries, these are the class boundaries, and so plot will be along x-axis class boundaries and along y-axis cumulative frequency, as I explained during theory. So if I just take this, for example, let me show you without any labeling. Okay, so if we just draw this, we can see, so this is the one, this is the points. Okay, this is the points that we have drawn, and if we add type, okay, comma, say type equal to for example L, only line. Okay, I'll show you with both. So you can see it is just giving a line, and if I give both line and point, then it will show me. If I run it, then it will show line and point both. Okay, and now some leveling we have done here, like already explained before, x lab, y lab, then along x-axis if we want to give our own points, already I explained it is similar. Then plotting character, then color, I want suppose it is blue, then line width. Okay, then cex. Okay, this all if we just see, just explore it. Okay, explore in the sense change the values and you see how it will behave. So you can see here it is appearing exactly the one which we want. Okay, so this is about your Ogive. So that's all. 3 numerical representation of the data. Okay, data visualization of numerical data. One is histogram, frequency polygon, and Ogive. Now we are going to see 3 more kinds of graphs or drawing, or you can say data visualization, when the data is in general categorical data like bar plot, then pie chart. Those are used in general to represent some categorical data. Then box plot we can use for both categorical data and for numerical data. Even bar plot also we can use for numerical data, but bar plot and pie chart mainly these are used for categorical data, non-numeric data. The implementation and the program of bar plot, pie chart and box plot, we will see it in another lecture. Thank you.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.